Lesson 5. Welcome. Today's lesson 5. We're going to be talking about domain and range. Our knowledge and skill is posted up here. You can read that. I'm going to hit the learning goal. What is it that Mr. Voorhees wants you to learn today? And it's this, that you are learning to identify the domain and the range of functions from a graph. That's going to be the key today. You're going to learn domain and range from a graph, and we're going to use inequalities, a thing called set notation, and verbal descriptions. Okay, that's how we're going to do it. You can read your DOL. I'm going to give you 4 questions where we prove our learning goal that we can identify the domain and range from a graph, and we'll do it with the inequality, set notation, verbal descriptions. Okay, so the 3 things that are necessary for you to accomplish this task is 1, you're going to have to determine if a graph is continuous or discrete. Second, we'll look for the least value, then the greatest value for domain and range, and then we will, third, write them using the proper way of writing, either inequality set notations, or if I ask you for a verbal, you'll talk out loud with me. That's the 3 things you'll need to be able to do to accomplish your learning goal. So with that, let's get started. When I look at a graph, there are 2 different types of graph in mathematics. One is called discrete. Discrete looks like a bunch of dots. Go around here. Discrete looks like a bunch of dots. Let's go ahead and write that in because that'll help you remember. Discrete looks like dots. Continuous means it's connected. So notice the words here I'm using it's called alliteration. Discrete looks like dots. Are the dots connected to one another? No. Discrete is dots. Continuous means the graph is all connected together. Make sense? Okay. So now, right here, this looks weird on mine, but on yours it makes sense. It says on the next page of the packet, you have a whole bunch of pictures. What I want you to do is write discrete or continuous, just a D or a C. What does D stand for again? What's the easier word to remember? Dots. C stands for connected. Okay. Your packet, I know they're really small, but there are 12 different ones right here. I'm going to pause the video. If you're watching at home, pause it yourself. Write in what you think is true. I'm going to give you about 30 seconds to look at these 12 and determine if they are D for dots, D for discrete, or C for continuous, connected. All right? 3, 2, 1, ready, go. So around the room, y'all got 100 across. So just call them out to me. A, what'd you get? D. I'm going to go across the side. What about this one? C here. C here. All those were connected. Good, except for this one, dotted. Okay, how about this one? C, connected. How about this one? C, connected. How about this one? D, it's dotted, discrete. How about J? Connected. How about E? D, dotted, discrete. What about F? C, C, and D. Okay, you got it. That's how we know discrete versus continuous. Big math words, the easier words to remember rather than discrete and continuous. What's the easier words to remember? Dotted or connected. Yeah, there we go. So when we write domain is always the x values. Domain is always the input or the x values. That's what that says right here at the top. Range, when we deal with that, that's going to be our y values. Now here, I want you to write something down. Did your teachers teach you when you learned domain? Dr. XY? Have you ever heard that before? I just learned it myself. We're going to call it Dr. XY anytime we do domain and range. Here's why. Did you write on your paper Dr. XY? The D, domain is on top of X. The R for range is on top of Y. That'll help us keep track. Domain goes with X, range goes with Y. Okay, when we're dealing with a dotted graph, a discrete graph, we're going to use symbols like this to describe the domain and range. If it's continuous, we're going to use these symbols here. Okay? Now, a couple other things to write down on here. I did not have good symbols for this, so we're just going to draw them in. If you see an arrow, add an arrow to your list. Actually, you know what? Put the arrow on this side. Put the arrow on this side. You don't have to erase. We're going to do a solid line on this one. Just a solid line on this one, but draw an arrow on this side. What I want you to put is that the arrow is not in the domain or range. The arrow is not in the domain or range. The arrow is not in bold. Is not in the domain or range. It's not letting me write lower, so I'm gonna have to, oh wait, extend page, yeah, well, there we go. Oh, that just made it too small. Hang on, let me come back. The arrow is not in the domain and range. Okay, if it's just a solid line like this, the line is in the domain or range. So today we're going to be paying attention to the x values and the y values. Domain means x, range means y. We're going to be talking about what values are there and what values are not there. These symbols will help us out as we go. This is like a cheat sheet for us. If you see an arrow, the arrow you treat as if it's not in the domain and range. It just arrow tells you where the graph is going. It doesn't tell you where the graph is. I'll say that again. An arrow tells you where the graph's going, but it's not there yet. A dot means the graph is actually there. Does that make sense? So right now we're in school. If you were drawing on a map where you are right now, would you put an arrow at school or would you put a dot? You'd put a dot. Now, we all want school to end so we can go home. If you drew a path to home, would you put a dot at home or would you put an arrow? An arrow, because we're not there yet. That's where we want to go, but we're not there yet. So arrow's where the graph is going, but it's not actually there. Make sense? Okay. Same with this open circle. Means the graph is not actually there. It gets close to it, but it's not actually there. Whereas this would be a dot. So maybe if you were drawing a map right now at school, at the cafeteria, you could do an open circle. You're really, really close, but you're not actually at the cafeteria. And that's not necessarily where you want to head. You want to go home. That's be the arrow. But the cafeteria would be an open circle. You're really close, but you're not quite there. That's what that one's used for. The dot means you are actually there. You are in my classroom. That would be a dot. Okay? And you would use these symbols accordingly. All right, let's practice some. So first, it says, what are the domain and range of this graph? Now, what we need to do so we don't forget, would this be discrete or would this be continuous graph? Discrete. Why? How did you know discrete? What did you remember? Discrete means dots. This is discrete. So now, if it's discrete, the way you do your domain is you list it in these squirrely brackets. You do a squirrely bracket and you just list the x value. So I'm going to go to my first point. What's the x value on my very first point? -1. You do a comma. And now we list, so remember domain means x, Dr. XY. Dr. XY. Domain means your x value. So what's my x value, my next point here? +1. Good. You do a comma. You always go left to right. It's just like run. Which way do we want to run out of my classroom? To the right. Yep. Okay. So you start left and you work to the right. You're running out of my classroom. Okay. How about the next x value? What's the next x value you see? 2. And then finally the last x value we see. 4. You got it. Now close your squirrely bracket and you got that one right. The 4 and my squirrely bracket kind of got too close together. Let me do it like that. There we go. Now we'll do range. So remember, domain meant x values. Range is going to mean y values. Okay, so here's how range works. Domain, we always run to the right. Range, it's kind of like you want your math scores to keep rising and rising and rising. You do it the same way. You want to keep rising up the chain. You start at the bottom and you work your way up. You don't want to start at the top and your grades just to go down over the year. You want to start at the bottom and make your grades keep going up. It's the same way as your grades. So the lowest value I see is right here. You can't, now it's covered up. These say -1, -2, -3, -4. That looks like it's a +5. It's not. What's that value? -5. So again, squirrely bracket. For discrete, you do a squarely bracket. -5 is the first y. Second y value, what's that one? -1, good. Third y value, what's that y value? 1. And finally, the last range value, 5. That would be your answer. And this was discrete because it was a dotted graph. A discrete graph. Cool? Not bad, right? Now, all these points are where the graph is because they're closed in. Because they're filled in, that means you actually are located at those points. Okay, so now let's take another look at a different example. Am I going too fast if I go to the next one? Let's look at example 2 here. Now, before we actually, it says, what are the domain and range? Before we actually do this, I'm going to ask you this question. Is this discrete or continuous? This is a discrete graph again. How did you know it was a discrete graph? It's dotted. Okay, when we do domain and range, I'm going to write up here, it's Dr. what again?
XY.
XY. The reason I do this is so you can see that domain means what type of values? X. Range means Y. Okay. I'm going to color coordinate again. Domain I'll do in X. Range I'll do in blue again, just to keep track. Okay, let's start with the domain. The X values. What's this X value right there? This one. 0. Good. I'll put a 0 down there. My first X value, do a squirrely bracket. For discrete, it's squirrely bracket is a 0. What's my second X value? Would it be this number in between 2 and 4, or would it be 5? 5, good. You go to your x-axis, which this one's your x-axis. Whoops. This one here is your x-axis. This is your y-axis. So yeah, you're looking at the x-axis. So the next value is a 5. Okay, what's our third value? 10. Fourth, 15. I'm getting the pattern on this one. This one has a pattern. 0, 5, 10, 15. 20, and then 25. You got it. Close your squirrely bracket, and you would have that one all correct. Now let's do some range. So what does range mean? Y value. So I'm going to connect each of these to the y-axis now to look at their values. So range, I didn't ask you in this one. Domain, I went left to right because that's the way we run out of my classroom. How about range? Do we want to start at the top and work our way to the bottom? Or do we want to start at the bottom and work our way to the top? Bottom to top. It's like your grades. You want your grades just to go up and up and up. So you start low and you work your way high. What's this lowest point right here? 0. So we start with 0. The next lowest point is right here. What is in between 2 and 4? 3. Good. Then I have this point. 6. The next one's an in-between value again. It's in between 8 and 10.
No.
9. Are you getting the pattern already? Next one will be a 12. And finally, the last one is right in between 14 and 16, which means it is a
15.
15. Close that up. And you've done example 2. Now, both of these were discrete. So since I've done 2 discrete, and you seem to be catching on pretty quick, how about this? I'm going to give you a DOL. You tried this domain range for this graph here. Is this discrete or continuous? Discrete. See if you can repeat exactly what I've done. Pause the video if you're watching it and you need more time to complete it. Okay, it's time now to look at a different type of graph. Now look at this graph. This graph is different. What do you notice about this graph? It's connected. So what do we call it if it's connected? Continuous is the word. This is a continuous graph. That's a big word. But what it means to be a continuous graph is that the graph is connected. This is connected, so it's a continuous graph. Now, remember, well, let me just write it up here. We had a saying about a doctor. What was the saying that I'm going to put up here? Doctor XY. Now, we're going to do that so we help remember what letter means what. So domain is going to be our X values. Now, let me ask you again. If you were going to run, domain X is run. If you were going to run on my classroom, which way do you run? To the right. So what that means is you start to the left and you run to the right. We're always going to start left. So here's how you do it. What number does this graph start at? How far left does this graph start? -4. Okay, go ahead and write down the -4. And then what we're going to do is we're always going to have this symbol, X, this symbol, and we're going to come back to the symbols in a minute, but they always run towards the door. They open towards the door. The alligator mouse, they're always going to open towards my door. Like you're running out the room. That's the way they open up. You run out my room when you want to go eat lunch. You got to go that way, out the door to go eat lunch. So that's what this symbol's doing. It's alligator mouse eating that way. Okay, now, how far to the right do we go before this graph stops? 2. We go to 2, so put a 2 there. Now, sometimes, I don't want to go too fast here. Don't write what I'm about to write in green. Sometimes the symbol gets a line underneath. Sometimes it doesn't. Sometimes the symbol will get more ink like that, and sometimes it doesn't. Here's how you know when it does. You look at this point. Now tell me, does this point here, this open circle, does that have more ink or less ink than the closed circle? It has less. So I'm going to write up here less ink. Now what does that mean? That means my symbol gets less ink. I don't put the line underneath. I leave it. Does this symbol, this dot, have less ink or more ink? More ink. So what does that mean? When I write my answer, this second inequality means the line underneath it because that dot had more ink. This dot means it's in the domain, and so you say can be equal to it. This open circle means it's not in the domain. It means it's close, but it's not actually in, and so you cannot be equal to it. And so that's how you would write your answer like that. Follow? Now let me do the range. Range deals with what values? The Y values. Now with Y, we go bottom to top. We don't go left and right. Left and right are X values. We're doing bottom to top. The lowest point on this graph is right here. Very good. You did not say 2. Why would you not say 2? You're correct. Why would you not say 2? What axis is 2 on? X. We're not talking about X's. What are we talking about? The Y. So this point right here is at 0. So put a 0. And then always do the same 2 symbols, but this time put a Y in the middle. They're always going to go that way. Now, what's the highest point on this graph? You work from bottom to top. The highest is 3. Put a 3 on this side. Now we go back to, do I put a line underneath or do I not put a line underneath? Let's talk about the 0. The 0 came from this point. Does this point have more ink or less ink? More. That means my symbol needs more ink attached to it. Put the line underneath. Now, the 3 came from this open circle. Did this open circle have more ink or less ink? So it does not get a line. It needs less ink on this symbol than that symbol. Okay, let me try another one with you. That was example 3. Let's try another one. Let's go to example 4. Example 4, what is the domain and range for the graph shown? So one more time, let's take a look at the picture. Tell me, when you look at it, does it seem like it's discrete or continuous? Continuous, good. What did continuous mean again? Connected. This is continuous. Which continuous is just a big word to say it is all connected together. We had a saying to help us with domain and range. It has to do with a doctor. What's our saying? Dr. XY. Which all that's telling us is that domain is going to be the X values and range will be the Y values. That's what Dr. XY means. So let's start with domain. Domain goes what two directions? Or X goes what two directions? Left and right. Okay. So which means you always end running out of my room, which means which way to go out of my room, that's going to the right. We end there. So that means we start on the left. The farthest point to the left is right here. What number would that be right there? It doesn't show a number. It's between -10 and -8. That's a -9. So put a -9 first. That's the farthest to the left. Then when it's continuous or a connected graph, you always do these symbols next. Those symbols come next. Less than X, less than. That's how you'd read that. Now, how far to the right does this graph travel? Farthest to the right is here. 3? Good. Put a 3 there. Now, technically, we're not done. We need to talk about more ink or less ink on a continuous graph. Does this symbol here have more ink or less ink? More ink. So what does it mean if it has more ink? You put the line under your symbol with the -9. Now tell me about this symbol. This one has less ink. So what does it mean if it has less ink? You don't put the line. Now, this one's range is a little bit tricky. And the reason the range is a little tricky is students so often think left to right, but range does not go left to right. Which two directions does range go? Up and down. And technically, you go bottom to the top. What's the very bottom point? Is this the bottom point? No, that is not the bottom of the graph. Where is the bottom of the graph? What Y value is the bottom of the graph? Perfect. That's your very first value because range goes bottom to top. The very lowest point is -4. Remember, we'll always do these symbols, just this time with a Y in the middle. That's read as less than Y, less than. Now, what's the highest point on the entire graph? What's your highest? You go bottom to top. What's the top point in the entire graph? Is this one it?
8.
The top point is 8. Okay, so now let's do more ink, less ink. On the -4, we haven't stated. Does -4's point, this point right here, the minimum is what you call at the bottom, does that have more ink or less ink? More, which means what for my symbols? Put the line under the -4. 8 is the maximum, the very highest point. When you look at this maximum, the highest point, the top, more ink, less ink. Jose, what are you seeing? This top point of 8, does it have more ink or less ink? Less. So what does it mean for my symbol? Does it get the line or no line? No line. Because it's less ink, it does not get that line underneath. It has less ink on the symbol. And so that would be my answer right there. Okay, now I've tried 2 of these. I want to see you practice this next graph right here. DOL number 2. I want you to try this one. Okay, so go ahead. Your turn. DOL number 2. If you're watching at home, just pause the video and give yourself a chance to work it. All right, example 5. I'm going to add in a new symbol that I haven't shown you today, and that is the arrow. So let me show you what happens with the arrow. You see how we have an arrow here?
Yeah.
Now, we're going to start with this graph, and I'm going to ask the same questions I've been asking. Does this look like a discrete graph or a continuous graph to you? It is a continuous graph. Y'all are getting good at that. What was the trick word that I said? Continuous means what? It's all connected together. That is a continuous graph because it's all connected together. What did discrete mean? Dotted. That's right. Continuous, connected, discrete, dotted. Good job. Y'all are catching on to that pretty good. Okay, so domain. Oh, one more thing. To help us out on domain and range, what do we write anytime we have to find the domain and range? Dr. XY. This just helps us remember what word means what. So domain is our X values. So show me with your arm in X-axis, please. Show me with your arm in X-axis. You see how Edgar? There we go. Your arm's going left to right. That's what domain does. It just cares about how far left to how far right. You always go from left to right because when we talk about X's, that's like run. You run out of my classroom, what direction? Everybody wants to run right. That's what we do. We start at the left and then we run to the right. So left to right. How far left does this arrow go? Ooh, good thought, but that's not right. Ooh, better thought. Still not right, though. Good thought, but that's not right either. Do you know how far it runs? It goes forever. Whenever you see an arrow, it means it goes forever. There is a symbol for this. It's a sideways 8. Have y'all ever heard of infinity? All right, that means a negative means it's on the negative side of the graph. This arrow is going to run all the way to negative infinity. Now, remember like what we said, if it's continuous, you're now going to do less than x, which is less than. So this arrow runs to infinity. But to the right, we don't run to infinity. Where does the graph stop going to the right? Ooh, we got the y value. Domain is x. What's the x value? 3. So put a 3 there. Now, an arrow, we got to talk about, does it mean more ink, less ink? And the way to think about this is not actually more ink, less ink. I want you to think about infinity. When we put a line underneath, that means we could be equal to it. Can you ever be equal to infinity? If you save up all your money you ever make in your entire lifetime, and you keep putting it in the bank, someday would the bank tell you have more than $100? Think that could be the case? Might show $100 in your bank account? If you keep saving, do you think you might get to $200? Well, let's say you just keep saving your whole life. Do you think it'll ever show you an infinity symbol? You've earned infinite dollars? No, it's not real. You can never be equal to infinity, so it's like it's less ink. An arrow, you're going to think of as less ink. Don't put the symbol there. Tell me about the 3. More ink, less ink on this one. More ink. So if it has more ink, what do you do with that? You put the line underneath. The arrow, you think of it as less ink. Because you don't have to fill it in. You can just go like that. That arrow is less ink. So we don't fill that in. Okay, so there's our domain. Now let's do the range. Range is like your rise. Which way does rise go? Show me with your arm. Which way does rise go? Up and down. Now, I said this is like your grades. Do you want your grades to start at the top and all year just make it lower and lower and lower? What would you rather your grades do? Keep going higher and higher and higher. So we start at the bottom and we work our way to the top. What's the bottom y value this graph ever seems to be at?
4.
Negative 4. Go ahead and add that in. That's a negative 4. This graph goes as low as negative 4. Now remember, you do the less than. Okay, it's Dr. XY. So range gets what letter? Y. Range gets Y. Negative 4 is less than Y, which is less than. Okay, here we go. How high does this graph go? Oh, good. You didn't say 6 this time. Why did you say infinity and not 6? Because it's an arrow. Arrow means it's going to infinity. Okay, tell me about this dot. More ink or less ink? More ink, good. So the less than by the -4 is less than or equal to. What about infinity? Can you ever be equal to infinity? No, you leave it less than. That would be your answer. All right, with that, let's flip over to your last page of your packet. Let's try example 6. Example 6. All right. Let's talk about this one. Continuous or discrete? I'm going to do a countdown. Continuous or discrete is my first question. What type of graph is this? 5, 4, 3, 2, 1.
Continuous.
Continuous. Ivan, I heard you most confidently. You were right. How did you know it was continuous? What did you notice?
An arrow.
Okay, so just for clarity, does an arrow make a graph continuous? No. What is it that makes a graph continuous? It's connected all together. The whole graph is connected together. But you are correct, by the way, that a discrete would never have an arrow because a discrete's just dots. It will never have an arrow. So that is a good observation, Ivan. Okay. There is a saying I've been putting at the top of the page each time to help us keep track of domain and range with X's and Y's. What have we been putting every time? Dr. XY. Dr. XY. Which means the domain goes with X, range goes with Y. So let's talk about our domain here. Show me an x-axis again with your arm. Show me an x-axis. What directions does an x-axis go?
No.
Two directions, left and right. So domain means how far left, how far right. When you look at this graph, how far to the left will it travel? How far left? Does it stop at -2? Oh, what does that arrow mean? Infinity. Because we're going left, this would actually be a negative infinity. That's how far left. Now remember, you do less than x, less than. We always do that. Okay, now how far to the right does this graph go? It keeps going. How'd you know that, Leah? It has another arrow, so we have infinity on this side. Now you can leave your answer like this. Oh, I forgot to ask you. Do arrows have more ink or less ink? Less ink. Good. So does that mean I need to put a line underneath or don't put a line underneath? Don't. Okay. You can leave it like that, or if you have two infinities like I do there, a negative infinity to positive infinity, you can also rewrite it. Sometimes people do this. This just means it's all real numbers. You can do X, E, R. And the R is usually a weird R that has like two lines. You can write it either way. Both of those are acceptable. This means all reals. I'll put that in black. What that means is all real numbers. All real numbers. That's what that symbol means there, if you ever see that. That weird looking R means any real number you can come up with, the X values would exist there. Whoops, all real numbers. Forgot the S. All real numbers. Okay, now let's do range. Now range is different than domain. What is range concerned with? Y values. Okay, show me a y-axis with your arm. Which way does the y-axis work? Up and down. But like your grades, you want to start at the bottom and make your grades always just get better and better and better. We want to start at the bottom and work our way to the top. So here's my question. Does this graph go down forever and forever and forever? No. How low does it go? I don't like that this graph isn't perfect. You want to pretend like it was shifted up just a tad? Approximately. How about that? Approximately, how low does this graph go? How low is that right there? Approximately 1. Do y'all want to say it's approximately 1? Okay, it goes low as approximately 1. Less than y, which is less than. Always do those symbols on a continuous. Now, how high? Remember, you go bottom to top. How tall does this graph travel? Infinity. How'd you know infinity? Up arrows. Both of those would make it go up to infinity, so add that in. We said this is less ink. Earlier in the lesson, I told you, I drew in a dot right there. I shouldn't have done that. Earlier in the lesson, I told you way back here that if it's just a solid line, the line is in the domain of range. That means if it's a solid line, you can put a solid dot on it. So what am I saying? Because this one is not dotted on the line part, you can put a solid dot. So you can add a dot to it. So does that mean more ink or less ink? More ink. That the 1 gets more ink, which means what for my symbol? Line underneath. Okay, now that you've seen all of those, I'm going to add, we have 2 DOLs to close up the lesson. You have this one, and actually, you know what? I might have you do, maybe I want you to do number 4 first. Okay, so try number 4, pause your video, and then come back and try number 3. Again, just pause your video right here. And then I'll come back and then you can pause your video here.